Dear professor, dear colleagues, today I'm going to talk about the paper titled Resources, Use Dynamics, and Interaction in the Tropic, Scaling Up in Space and Time, made by Gile et al. And published in the journal Agricultural System in 2006. As an introduction, we know that the agricultural is a very complex system, having like many different factors involved. So why we're trying to explain only using like single model? That's very unrealistic. So we're trying to propose like in this paper a way to put like the different several factors to trying to explain how they work together, how they interact, and how they produce they can produce more. So at the same time, the paper states that the soil fertility is a very limiting factor in African country. That's something very clear that if we can improve this point, we can gain a lot of in terms of productivity in this region. Also talk about from the potential of the technology they can have for improve agricultural production, but at the same time, the lack of impact that they have. This could happen that sometimes farmers are not willing to take technology since cultural reason, technology, educational reason, economical reason. So this is also something that we need to think about it. So the integrate analytical framework called NUANCE is just acronyms for nutrients used in animal and cropping system, efficiency and scale. It's like a way to try to make the complexity of agriculture a little bit more simple to understand and to improve. Analyzing the key components of the farm, we can see like how, for example, resources allocations occur, like from chemical fertilizer or from the animal who produce manure. They can both go to apply fertilizers to the plants, and this both plant can go to, again, maybe to feed animal or maybe provide food for people. At the same time, we cannot forget that these animals could be growing in agroforestry systems, or we also have alternatives like a green manure. So all these factors play like a role in this very complex system. So we can find like different sources of the nutrients, and also that's something that is really make a remark. This paper is the distance from home to field also play a big role. The input of food of production we can explain here in the first graph. We see the food productions per field. The farm type 1 and 2 are the most richest farmer. Farm 3 and 4 are medium farmer, medium income farmer, and type 5 are the poorest farmer. So when we talk about production per area, closest field and middle distance field are who are the producing more quantity. When we talk about mineral fertilizers used are the richest farmers in a very remote field and close field who are more who are the most who are using this source of fertilizer. But in organic fertilizers use, this one, we see that the home gardens and close to field gardens are who are the most uses these organic fertilizers. Probably because it's more difficult to transport to longest distance. So that's also make a lot of sense. Simplification do not show trade-off. That's something like when we try to make only simple, a complex system, it's something usually this happen. But using this nuance, we're trying to show the trade-off but using very simple model. So it's like it's a way to tackle this problem of don't cover the trade-off that we have when we go to from complex to a simple model. For scaling up, we cannot forget that farmers also, some farmers depend not only from the income from the farm. Many have off-farm income, and this factor also play a role in the decision making if they are going to take. So off-farm environmental really affects these decisions. And for example, labor constraint is very clear that if we are like producing some kind of field and we have a peak season, and if we don't have labor, we can really lose a lot of productivity only for this reason. So this factor is really critical in some point. As well, land and nutrient can be dynamic sources in the way that they can vary depending of if we are renting or we are owning the land, for example, or if the nutrient, if we are applying organic manure, chemical manure, this also will make a lot of changes in the system. So in this other approach, we can see like resources use efficiency using this example. For example, we have resources, capture efficiency, conversion efficiency, and the interaction with other factors. Think about maybe mobile nutrients. Mobile nutrients go into the plant in a mass flow inside. That's the one of the way that the plant take the nutrients. In the plants, they will produce more tissue, more leaf, more roots. They will help the plant to grow. But at the same time, if we have water limitation, they can really affect all these other steps. So this is one way to really think about which are the major constraint steps. And this other example about the potential production, we can show up the grass production in the Savannah Mali, how will be the potential production in terms of biomass production, and what is the actual production. So all it is that make the different is the different efficiency of the use. At the same time, we have this other example in the nitrogen fertilizing rate. They can have like, here we have like on-farm trials. We have so like how the farmers crop, and we have some station here. A station for developing, for example, new technology, or to make a good example of what will happen if we use like in a best efficient way our nutrients. So we can see all this gap probably producing because they have a lack of technology or different practice or other factors who play a role in here. Resources at farm scale, we can check like the variation of in the management of the farm for in different ways. For example, how distance of the field play a role. In this way, if the normally when the is close to the home, it's more easy to go, for example, to take out some weight, so you can put more pressure on that. Also, if you have like more fertilizers in that, because it's more easy to bring it, you will try to plant in a more high density, or trying to plant early because you really expect to have better yield, to make a good use of time. Also will depend of if the organic type of organic manure that you will have is how you will use. But in general, close to the home, better result. Also, short-term dynamics in the farm will be more relates always between the water availability and the timing of the application of the nutrient, which is also a more seasonal result. In the long-term dynamics, the role of clay and soil during the decomposition process play a big role, and also how much organic matter do you have in the field. But organic matter in the long term is not very good understood according to what the papers say. And in this graph, we can see the efficient use at farm scale. This is a graph who shows the carbon storage between uncultivated fields and more cultivated field or exploited soil. And here we have the quantity of clay plus silt in percentage. And it's very clear that if we produce in a very highly intense way, we start to lose also carbon in the soil. So that makes sense because when we try to restore some degraded field, we always need to invest in nitrogen before, because with the nitrogen we can increase like the production of biomass, and with that together increase the quantity of carbon in the soil. We cannot deny also that in the political and socioeconomic environment that the farm are used to work is also important. This create like a condition, for example, to futures development in the area of research and development, but also they can show like weakness that the current policies can have, or also opportunities that that one country can take to improve the agricultural production. At the same time, policies can affect, for example, fertilizer market. The example of lack of sulfur in Zimbabwe. This happened according to the text that if we, for example, regulate fertilizers market, we can easily, like in this case, for example, in Zimbabwe, was mandatory to put certain amount of sulfurs in all fertilizers. But since the regulation happened, this was no longer mandatory. So fertilizers doesn't need to put more sulfur, and in the long term, they produce like a deficiency in many regions of Zimbabwe due to the policy. Transparency and clear information of policies for development of rural areas is huge, important. It's very important for farmers to take the best decision with the most transparency and the most clear information, because this really can lead to have, for example, if one big group can control certain information or avoid to say wrong wrong things, can really lead to make bad use of information, which could be really make change the agricultural system in this region. So final analysis of this paper is like in the short long-term visions. It's really complex to try to solve this, because it's like short needs are related to immediate needs, but to make sustainable the system, we need to invest into the future. And sometimes people is only is more taking care about what will happen this year more than what will happen like in the next 10 years. Also, we need to try to don't draw it into complexity in the way that complexity of the system can really lead to chaos. If you really give, for example, a lot of information or factors, it's really difficult to move forward. So we need to find a way and to make this system more simple, but without losing important factors who determine, for example, productivity. So also heterogeneity must be taken into account in the way, as well as the labor endowment. That's because not all the farmers are the same. Not all the farmers have, for example, the same infrastructure or the same knowledge or the same type of soil. So this is always need to take into account and before to give some recommendation or trying to understand how the factors work. Everything is very, very heterogeneous in general. Other socioeconomics and agroecology factors results in multiple scenarios. This means like with socioeconomics and agroecological results, we can create multiple scenarios and then choose what we can do for the future, or which type of solution we can choose. And from complexity to simplification, is trying to understand the important factors. It's trying to make like a how to make positive change. So understanding which are the most important factor here.